Dear students, today I will discuss with you some important MCQ from the chapter Atomic Structure. The first question, which cell would be the first to have G subcell? So we know S, B, D, F, okay, but we do not know what is G. So generally K, L, M, N, okay. Now then after N, which cell is present? That is your O, okay. So question number 1, K, L, M, N. After N, there is a cell known as O. Okay. So N is equal to 1, N is equal to 2, 1, 2, 3, 4, this is 5. N is equal to, this is 5. Okay. So G cell, K, L, M, N. In O, there is a G subcell, G subcell. Okay, that is for G. What is the value of azimuthal quantum number? It is 4. So N is equal to 4 plus 1, that is 5. Understand? So choice D is the choice which subcell would be the first to have the G subcell, that is D. Okay, next. Assuming the velocity to be same, the wavelength of waves associated with which of the following particle would be the maximum? Okay, so we know question number 2. We know de Broglie equation, lambda is equal to h by mv. So lambda is directly proportional to 1 by m, that is mass. So which mass is less, that is velocity, lambda is more. So it is choice A, an electron. Next. For p electron, the orbital angular momentum is what? Okay. What is angular momentum? Question number 3. Angular momentum, orbital angular momentum is equal to the formula root over L into L plus 1 multiplied h by 2 pi. Okay. Or root over L multiplied L plus 1 h by 2 pi, it is taken as another symbol like the h bar. Okay. So you for which orbital? That is p electron. P is electron, L is equal to 1. So you take for p electron, L is equal to 1 plus 2 h. Okay, that is root 2 h. So root 2, it is known h bar. So your root 2 h bar. Choice B is the correct answer. Next, which of the following electronic level would allow the hydrogen to absorb a photon but not emit a photon? Okay, to absorb a photon but not emit a photon. So we know when there is an emission, it should come to the next lower level. If the lowest level is 1s, you see, if it is 1s, then its lowest level is, there is no lowest level. So choice D is the correct answer. Next, an atom which has 2k, 8l, 18m and 2n electrons in the ground state, the total number of electrons having magnetic quantum number m is equal to 0. Which one? So see, how many electrons are there? 2 plus 8 plus 18, this is 28, okay, plus 2, that is 30. So question number 5, 30 atomic number 30. So if this is so, you write all the electronic configurations. Okay, 1s2, 2s2, 2p6, 3s2, okay, then 3p6, okay. So it is your 10, and this is what? This is your 8, 28. Then comes to your 3, then 3d, okay, 3d2. So you have to write all these numbers, spin magnetic. N is equal to 1, that is N is equal to 1, L is equal to 0, okay, that is 1s1, 1s2. Then you write N is equal to 2, L is equal to 0. Similarly, you have to write. So for every subcell you have to write the magnetic quantum number. So you will get the value 14. Okay. Next, the probability density curve for 2s electron appears like which one having 2s electron. So you see question number 6. So for this is 1s, okay, and for it is 2s, okay. So if it is 2s, then there is here some nodal point, nodal space should be there, okay. What is nodal? Where there is no electron is found. So if this is so, you see the probability density curve for 2s electron, it should be like this. It should be like this. But you see here at 2 points it is touching. At 2 points it is touching the x-axis. So actually this is wrong. But what should be? What is the correct? It should be like this. It should be like this, touching one place and another place there is no touching. So exact verb like this, but you have to for here you have to write this one. Okay, so choice A is the correct answer. Next, the number of radial nodes in 4s. The number of radial nodes in 4s and 3p orbitals are respectively radial nodes. You see, for question number 7, 4s. 4s, what to write? You have to see for 4s, for nodes, radial nodes. Okay, there is a formula to find out the nodes, that is n minus l minus 1. It is the formula. So for n 4s and 3p, you write 4s, 4 minus l 0 minus 1, it is your 3. For 3p, 3 minus 1 minus 1, so it is 1. So choice 3 and 1, B is the correct answer. Okay, which of the following orbital is with 4 lobes present on the x-axis? 4 lobes. You see question number in that dx square minus y square, dx square above the lobe, this is known as dx square minus y square. So choice D is the correct answer. What will be the longest wavelength line in Balmer series of spectrum of hydrogen atom? So the visible region is question number 9. Visible region right from 400 nanometer to 760 nanometer. So in this range you will get the highest is 656 nanometer. Okay, next, so choice B is the correct answer. Next, in hydrogen atom, energy of first excess state is this much. Then find out the kinetic energy of the same orbit of hydrogen atom. You see question number 10. Okay, so you know kinetic energy by E total is equal to minus 1. Therefore kinetic energy by E total is equal to, kinetic energy is half mv square, this is minus half mv square. Okay, so kinetic energy is half mv square. Potential energy, what is potential energy? Potential energy is equal to minus z square by r. So in the electrostatic force and centrifugal force, electrostatic force and centrifugal force, electrostatic force, this is electrostatic force and this is centrifugal force is balanced. So what is electrostatic force? Electrostatic force is ZD square by R square. This is your MB square by R. Okay, so potential energy is equal to minus MB square is equal to MB square. Okay, so total energy, you see, total energy is equal to half MB square minus MB square. So your half MB square minus MB square. So you will get minus half MB square. So what is minus half MB square? Your kinetic energy is equal to minus of minus 3.4. You will get plus 3.4 EB. So choice A is the correct answer. Next, two particles A and B are in motion. If the wavelength associated with the particle A is this much, calculate the wavelength associated with the particle B if its momentum is half of A. So what to do? You see, question number 11. What is given? Wavelength of A is equal to h by momentum of A. Okay. Similarly, wavelength of B is equal to h Planck's constant h by momentum of B. Okay. So then to divide wavelength of A by wavelength of B divided by h by PB. So h cancel. You will get PB by PA, momentum of B by momentum of A. So this is your, say, PA, 1 PA, and this is 2 PA. So you will get lambda A by lambda B is equal to half. That means lambda B is equal to 2 lambda A. Okay. So your lambda A is given how much? 2 multiplied 5 multiplied 10 to the power minus 8. Okay, so you will get this is 10 to the power minus 8 equal to 10 to the power minus 7. This is in meter, so in second 10 to the minus 5 cm. So choice B is the correct answer. Next, question number 12. Total number of spectral lines in ultraviolet region during transition from fifth X-ray state to first X-ray state is how much? You see, question number 12. Okay, the first excited state, this is n is equal to 2. Okay, why? Total number of spectral lines in ultraviolet region during transition from fifth excited state to first excited state. So first excited state means second state, second n is equal to 2. Okay, so second excited state, this is n is equal to 6th. Okay, so no transition will happen. Okay, that is first several. Okay, why this is so? Because no transition will be up to first level. No transition will be up to first level. Okay, because no line will appear in the Lyman series. No line will appear in the Lyman series. Okay, in the ultraviolet region. Okay, students. So choice D is the correct answer. It is 0. Okay. Okay, students. Have a good day.